till now we have covered I think two major vectors. One is the moment of a force about a point, moment of a force about an axis. These two are very important vectors which will be used extensively in solving all the problems in future. Now then one more last important vector which we will be discussing today is the couple moment. Okay. So, I think the number should be 6, right. So, couple moment. Now, what is that? So, in order to understand this, let's see. Suppose I draw a set of axes like that. Say this is x, y and z. Okay. And now we have two forces now. Okay. Earlier in the other two vectors we had a force, a single force and a point. Now instead of a point we have another force. That means we have two forces with some special properties. I will discuss that. So one force looks something like this. So let me call this F. The other force is almost equal to this in the sense that only the sense is different. Okay. If you remember the distinction between the sense and orientation, orientation means the angle which the arrow makes with the axis, and sense is whether it is upward, rightward, downward, leftward, all those things. Okay. Now the next force is exactly like this, means but in opposite sense. Okay. Magnitude is same, orientation is same, just the sense is different. Now that I will call say minus F. Why minus F? Because equality of forces will tell that wherever you keep it they are equal, and because only the sense is in the opposite direction, it is minus F. Now if that is so, and then one more point, you can have them on anywhere on their line of action. Okay. So it is not necessary that they should be like this side by side. They can be, these lines are bad. Okay. So these are also bad, and yeah, let's accept them to be parallel. Okay. Now why this is such an important thing? Why having such restriction on two forces have such an importance? The fact that there are two forces which are equal and opposite in nature makes the system free of forces, right. Suppose you have a body, say you have a body, and on that you apply say one force like this and exactly an opposite force like this, then the net force on the body will be 0, right, because the forces, when I say force, that means the pushing or the pulling effect, that is completely cancelled out, right. The only thing which now remains is the twisting or the turning effort. So that is why this couple moment is so important. It provides a pure form of twisting, right. For example, pure form of pulling or pushing, how do you get? When you have a body and suppose this has a center of mass here, and if you push it along that, then you can create a pure kind of pushing or pulling effect. Okay. But anywhere else if you push, then you will have both combination of pulling and pushing effect along with a rotational effect. But when you have these equal and opposite forces acting on it, they will cancel each other and a pure form of rotation exists. That is why they are important. And some more important interesting properties which we will discuss about them soon. Okay. Now, then if there are such forces in the system, how to calculate the moment caused by them? That is, again when I say moment, it means the turning, the net turning effort. How much is that? For that, what you need to do is, anyway, first let us again discuss in the conceptual sense. Okay. So, if the distance between them is say d, okay. So, if, and then again please note that these two vectors are in space, and the distance also, this distance vector also has to be measured in 3D. It is not on the plane and then they are hovering somewhere. So, this d has to be properly measured. So, that distance times this f will be the couple moment. So, this will be nothing but f times d. So, this is the turning effort, but how to get it so in an usable form, or in most complex situation how to evaluate this exactly the way we did for other two cases. The point is, or the trick is, you choose any point on one of the line of action of the forces, then pick any other point. Now picking of these points are based on your convenience, based on the geometry, the situation, the problem, basically the problem definition. Based on that, you pick these two convenient points, join them like that and call this vector say E, not a hat, vector E. Okay. Then your E crossed with F, sorry, is what you will get as this couple moment. This is the general form which you can always use in whatever complex situation you are in. Now, why does it work? The same way, right? If we see this, if you consider this angle as whatever angle alpha, E sin alpha will give you the distance of this, right? The way we did for moment about a point. So, E sin alpha will always give you this distance. Wherever you choose does not matter, based on that the alpha will change, and based on that the d will be fixed. And so this is what you have to use. Now, once you accept that this is how you calculate, you can prove a very beautiful and important character of this couple moment. Actually, one before that, what about the direction of this moment? Now, to find out the direction, what you need to do is you try to turn E towards F, okay? Then you will get the direction, okay? Or else you can just see that you join this like this in a right handed rule, again you will get the moment in that direction, okay? So basically E cross F will tell you that if you turn E towards F, the right hand thumb in whatever direction it points, so that is the direction of the moment. So, if you want to show it here, maybe somewhere like that, you know. Something like that. Okay. So, now the point which I was trying to make is this couple moment is completely independent of the coordinate system. That means you are free to move it anywhere. That means you know now what it is called a free vector. Now, how do you prove it? To prove that, can I do like this something? That also has come here. Okay. So, I should have chosen a smaller thing, maybe, yeah. So, I need some space, so I have just moved it. Okay. Now, let's see what we can do. We can suppose we create maybe another coordinate system. Okay. Now, let that be called zeta, eta and xi. Now, if I draw say lines from here, I have chosen this a bad angle, so that it's, anyways, does not matter, and from here to that location. Okay. Now, your E, whether you look from this coordinate or from this coordinate, the vector E is always the same. For example, suppose this is say R1 and this is say R2, and say this is R1 dash and this is R2 prime. Okay. Now, E is the same which you get R1 minus R2 is also equal to R1 prime minus R2 prime. They are same. And why that makes sense? Because see, why did you even get this? Now, if you consider this to be origin, just try to see why this is also a moment from another perspective. You see this. Now, the moment of this force about origin, moment or about origin of the force F1 is equal to what? R1 crossed with F1, F. Then moment of minus F, okay, about O is minus R2 crossed with F. This minus is because of this F. Okay. Now, the total moment about O because of both of them should be addition of them. So, the F will just come out and you will get R1 minus R2 crossed with F, right, and this is nothing but our vector E, fine, and that is how you got this E crossed with F, giving you the moment. But then once you see this in this form, you can quite easily realize that it is completely independent of the coordinate system, because the same vector E you will get from wherever you want to look it, right. So, now this shifting the coordinate system is as good as shifting the vector itself, keeping the coordinate system intact, right. So, then you can say that this vector m naught is a free vector. it doesn't have any change in effects if you move it around. So that is what is a very important free vector, which you can use. We will see in the next class that in getting the resultant force of a complex system of forces, this freedom of moving the couple around will play a major role. That will make the solution process quite easy. Okay. So that is a very important point which I wanted to convey about the couple moment. Okay. Any other thing which I wanted to, yeah, there is one more important thing, how to add couple moment. In fact, the mathematics of adding couple moment is exactly the same as adding any two vectors, but there is slight fundamental which needs to be understood about addition of couple. So that I will put in another segment. Okay.